Speed is a scalar quantity.
This and this and this. You're so noisy. What are you talking about? Acceleration and velocity. I don't get it. Physics? Yes, I still have to pass this homework due tomorrow, but I can seem to understand any of it. Oh my, we have homework? Yes, I just mentioned it a while ago. I don't get it. We should seek help then.
I have someone in mind.
You scared us! Were you there this whole time? Did you hear our conversation?
Yes, yes. Anyway, I'll go for help now. We need help for our physics homework.
Hello students, this is your Savvy Scholar agent Dixie Barrera. I have received a call that you need help for physics homework. So I'm here to talk about your concerns, which is acceleration and velocity. The word acceleration is often used to describe a state of increasing speed. So when the velocity of an object changes, it is said to be accelerating. John Jay decides to jog at his school's ramp that was located near the gym. He accelerates uniformly from 2.72 meters per second to 5.39 meters per second in 3.57 seconds. Determine the acceleration of John Jay using the given values. John Jay decides to jog and accelerates from 2.72 meters per second to 5.39 meters per second in just 3.57 seconds. The values given here are 2.72 meters per second for initial velocity, 5.39 meters per second for final velocity, and 3.57 seconds for time. To answer this question, we have to use this formula. A for acceleration is equal to delta v divided by delta t. Delta v stands for the final velocity minus initial velocity. As we input the values into the formula, it would be like this. A is equal to delta v divided by delta t. Since delta v is final velocity minus initial velocity, then we would input our values to A is equal to 5.39 meters per second minus 2.72 meters per second divided by time, which is 3.57 seconds. Then after subtracting the final and initial velocity, we then get 2.67 meters per second divided by 3.57 seconds. And divide the two terms and the final answer would be 0.75 meters per second squared. Now that we've finished acceleration, let's proceed to velocity. Velocity is commonly associated with speed. However, these two quantities aren't the same. Speed is a scalar quantity that refers to how fast an object is. On the other hand, velocity is a vector quantity that refers to the rate at which an object changes its position. In a friendly race between two friends, Mark wins the race by 12.47 seconds than Michael. Mark's velocity was calculated to be 52.13 meters per second. A. Calculate the time that Mark traveled. B. Calculate how fast Michael was. C. Calculate Michael's velocity. So it was said that these two friends, Mark and Michael, decide to have a friendly race. Mark wins the race as he was faster than Michael. Then we were given three follow-up questions. First, calculating Mark's time. Second, calculating how fast Michael was. And lastly, calculating Michael's velocity. So first, we need to calculate the time that Mark traveled. The formula we need to use is average velocity is equal to delta x divided by delta t, where delta x is your distance or displacement, and delta t is your time. So 52.13 meters per second is your average velocity, equal to 2,000 meters, which is your delta t or your displacement, divided by time, which results to 38.37 seconds. Second, we're going to calculate how fast Michael was. The formula for this question is just adding time. So to add 38.37 seconds plus 12.47 seconds is equal to 50.84 seconds. Lastly, we're going to calculate Michael's velocity. So the formula you're going to use is like the first one. Average velocity is equal to delta x divided by delta t. And we're going to input the values given. 2000 meters divided by 50.84 seconds is equal to 39.34 meters per second. One-dimensional kinematics has been concerned with the multiple means by which the motion of objects can be represented. This means that their representations could be the use of diagrams, equations, words, and also through graphs. The first graph I'll explain is the velocity versus time graph. In the velocity versus time graph, there are two ways to consider. First, constant velocity, and second, changing velocity. For example, consider a bus moving to the right with a constant velocity of 10 meters per second. We all know that an object moving at a constant velocity is an object with zero acceleration. If the bus is at constant velocity, then our time graph would be like this. Since it is moving constant, then it is only in a straight line. Now, consider the bus moving to the right with a changing velocity. This means that the bus is already accelerating to a positive or rightward direction. If this data was graphed, it would look like this. Since the motion was described as changing, a positive velocity results in a sloped line when plotted as a velocity time graph. The slope of a position graph represents the velocity of an object. So the value of the slope at a particular time represents the velocity of the object at that instant. For example, in this graph, the times t is equal to 0 and t is equal to 3 seconds is positive since the slope is directed upward. The slope of an acceleration graph represents a quantity called the jerk. The jerk is the rate of change of the acceleration. For the acceleration graph below, the t equals to 3 seconds is positive since the slope is directed upward.